Okay, hi everyone. This is the second session going over the caching, arranged caching PR. Paul is presenting, so let's start. Let's start from where we left off last time and go from there.
Yep. So for range rate, last time I did not mention is only the read object stream path is affected. Last time we started looking to read object stream after looking to API. So and then I want to go back to just to try to reiterate this function. This function is basically it's a conversion point that handles both range rate and normal rate. Normal rate basically is the entire object rate. Okay. So this file or this function handles upload to cache, okay, through a cache stream, and also can pipe the hop rate stream to a range rate stream because of sometimes if it's a rate as range rate, we need to return the specific range to as recline, and then that's this basic function. And I actually created a diagram to show the just high level. It may not be a really accurately reflect the code, but that's what the sequence or the calling flow is. It's kind of mix and match. I kind of mix. On the up level, we have the range object stream. Okay, so there will be a 3 path high level. Okay, excuse me. So if it's an entire object I cached, so basically on that path we just call the cache read object stream function. Okay, NB namespace NB is underscore NB is for cache bucket. And then if it's an entire hop rate, remember last time we talked about there's we can decide there's a function to determine whether hop rate is the entire rate or range rate. Okay, if that function returns say are going to perform the entire hop rate, then actually you're going to directly call this function. Okay. If it's a range, if hop rate is a range rate, it's going to call this range rate hop object stream function. We can last time we kind of stopped at looking at this function. Okay, we will go over it after this slide. So and inside this function, it's going to check object not in cache. If its object is not in cache, right? So you actually fall back to read hop object stream. Okay, if we have some parts in cache, objects in cache, then it's going to call cache read object stream function with missing part getter. This is a function supplied into the read object stream of cache bucket. Okay. So what this does is if there's any part missing, okay, the object IO will call this function to get part. So this function of missing part getter will call read hop object stream to get part. So that's high level of flow, how how it looks like. In the end, pretty much, if a read, if hop read is going to be performed, this function handles all. Okay.
Yeah. So I have a question. So I understand the flow. It seems like seems like I understand the reasons behind it, but one thing I don't understand, or maybe I think maybe is a way we might be able to collapse a little. So some of the options here is that how do we decide what are the I/O operations or metadata operations we do in each step? So in the first step, we just check for the object metadata in the cache, right? That's the first question we do.
Yeah.
And then we can decide. So then there is the question of what can we decide by that lookup, right? So we can decide first of all if the if we are going to the entire hub read flow because the cache is empty, right? That's one option.
Yeah.
But we don't know if it's one of the other cases still, because we don't know if the reason is that just it's partially cached or that it's entirely cached. And we are using the flag of partial object to identify that, right?
Yeah.
Okay, and then we also have the the burden of updating this flag when we fill up we populate the entire cache in order to optimize, so to speak, this path, right? That's the case.
Yeah.
Yeah. Okay.
Yeah.
So go ahead.
So like we talk about whether that partial object flag is needed or not. It's just for, as I mentioned before, it's just for like programming or testing purpose. Programming means like for non-cache bucket, it's going to validate whether you have to supply certain like parameters like e-type when creating objects. So, but basically, if without that flag, we can, when this function is called, we also same thing. We can at this path, we can also supply missing part getter in here as well. So basically, that should work without, if we don't have partial object flag.
The assumption is that if it's not partial, it won't be like the missing part will not be called, and that's it. It's the same path completely.
Yeah.
Right. So what I'm trying to claim, I think that my claim here is simple. Like you said, I think we first of all, this is a minor optimization in the sense that it doesn't really allow us to prevent from any meaningful lookup or anything in this path. It's mainly about code path, but even there, I'm not really sure about the optimization in this read case. And I think the burden of updating this would be, if we can avoid it, it will be easier for us to stabilize this the logic, regardless of. And since we don't need it much, then maybe we should keep it out of the scope of what we're doing right now, so that we also focus on these paths more.
Okay. Yeah, the only case scenario with this implementation, the update case is just in the eviction case. That's need to be changed. Yeah, only for eviction case.
And right, and simplified, right? That's what you're saying. Yeah, so we don't need to update, right? Yeah, I agree. And I think then it becomes a more straightforward path, right? Because you sort of take out the left side here, and it just becomes like you have just a single step in the middle between reading directly from the hub or reading through. I mean, eventually both of them will do the same, right? Because you end up at the same. But in one case, you don't even sort of check the mappings. I don't think this really makes. I mean, it's right. So it makes real sense, because that's exactly how we will structure it in the code, and the functions will limit what we do, so that only we check the mappings only in the range read hub object stream.
Yeah,
like
then yeah, if you take out that, if you take out partial object property, then what happened to to a non-cache bucket if there are some parts missing? Because I mean, I'm not that familiar with how invocation case work for non-cache bucket. So how that should be handled if some parts is missing for object in non-cache bucket?
So this will just result in so if the intention is this, if missing means that the metadata is missing for this part, right? Like in this case that we designed here, then the answer is that all of the background work should not really be affected, because we just scan the parts or the chunks, so we don't really check for the logical range of the object in the background processes. But when we do come to read the actual range, we will just fail. I mean, the request will just close in this case. But I mean, this is okay, because that's really the handling. If you stop at the namespace NB level and don't supply, like you said, a missing part function, then it's okay to fail, because you don't have any fallback. But when you supply the missing part function, this is a fallback that we have, that we can read from hub, right?
Okay. Yeah. So then in that case, certainly we can take out, just remove the partial object flag, partial object property from the object metadata.
Yep.
So make the case will be simpler.
So the meat of this is the read hub object stream function, right? That's where most of what we're trying to achieve.
Yeah.
Okay.
So so I think last time we stopped at this range read object hub stream. Okay. So by this one function, just it's going to be called. It's kind of intermediate function step if hub read is a range read. So I can just jump to that function. Okay. So that's is that like a font too small, or is okay size?
We can you zoom in a little bit more? It's a little bit small.
How about?
I think two more.
Two more?
Okay. One or two.
Let's see. One?
That's better.
Okay.
That's better already.
Okay. So what the first step inside this function is going to check whether we have this object cached. Okay. So if it's never been cached, basically we never been cached, we are going to read a lined block. Okay. A line part, I will say that a line part. Okay, I probably certainly mix block and a part. But in my mind, block is just basic. A block. Part consists of multiple blocks. Okay, so if objects never be cached, then we're going to find out what is a lined part range. Okay, based upon the start end of the input S3 request. Okay. So those are basically these two lines, calculate start and end. Then we call that the basic functions to read to read this aligned part from hub. And remember, this function will also going to store that part into cache as well. Okay, so that is this if what this if block does. Okay. Then if we have we have the object cached. Okay. So which means like we have the object metadata has been cached some parts has cached before. Then that's fall into that path. We're going to supply a missing part getter function to to cache read object stream. Okay. So that's
Paul, just to make sure,
yeah.
have we? So in this case, we are already after the checks to revalidate the object, right? So we did all the checks from read object metadata, right?
Yeah.
Okay. So now if we have the object, it means that it's been validated or revalidated.
Yeah, that's right. Yeah.
And now we use that information and decide if we are going to use the ranged version or the full version. And okay, go ahead. Sorry.
Yeah.
Just thinking.
So yeah, it can probably pop up that where's my PowerPoint. So basically, that's in this path. So here, I did not cite. That's another scenario. Yeah. No, what the object not in cache scenario is working here, right? Okay, that middle path. Then if I have object already cached, then I'm going to call read object stream of a cache bucket with missing part getter function. Okay, so missing part getter function, and that's what sets the missing part function here. Okay. So that API is going to have a start end, which is supplied by object IO function. Okay. So when there's a missing part, object IO function will go later on. Will invoke this missing part getter with the start end of the missing part. And then this one we're going to call read object stream. We'll try to read that part.
So by the way, why aren't you doing alignments inside? Why do you have to?
Alignment. Hold on.
I see that in both cases where you call it, you align before.
Yeah, this one doesn't have to be aligned. It seems passing here should be already aligned. Okay, doesn't have to be aligned again. It just try to make sure. I guess it's a redundant code because because when part is stored into cache is already being aligned. So whatever the object IO when they called missing part getter, so those parts should be already aligned. So those don't have to be called.
Okay.
Yeah, I can double check. Remove those. Yeah, don't have to be called.
So I would take either way, but if I would leave the alignment, I would probably do it inside the inner function rather than here before.
Oh, you're talking about in the session in here?
Inside the read hub object stream, right? Okay. Where you send that aligned offsets. So if you want to make sure every hub read is aligned, I would put it inside, and I think it makes sense, right? It's just number alignment. It's not really cost. It doesn't cost much, so we could do it even if it's redundant. But
sometimes it's not actually aligned. One of the scenario is if the object is small, right? Hold on, object is small. We read, no, forget it. Yeah, it's always a line. Sorry, it's always a line.
Even if you need more information, I mean, this function can have the information and make sure that we have the logic of alignment logic in one place, I suppose. I mean, I would just make sure that we align in one, like have all the alignment done where we are about to read, maybe something like that.
Yeah.
It's easy to get lost with
Yeah.
number
Yeah.
calculations.
I will note that.
Okay. The other comment is more of about how to write async code. So I think you've done it pretty good in the sense that you have all this here, but you mix the sort of promise, then and catch callbacks, and you don't really need to. So essentially, what you'd be able to do now without if you just await like the initial promise, you can await twice, right? So what you can do is wait for the stream to return first, saying something like, await. Maybe I can annotate here. Let me see if there's an annotation. No, I don't see a way to annotate. So you could await the response from read hub object stream and get back a read stream after the await returns, right?
Okay.
And the second step would be to read or to pipe this stream, right? And so you don't need to use callbacks mixed with awaits that much. You do need the construction of the promise if you want to, to wait until the stream ends. That's a case we always do. But I think specifically for what you're trying to do here, which is to buffer everything, we have a utility. I think it's in buffer utils or stream utils, one of them, that would read, and I think we'll even join all the buffers from a stream. So you can await a utility function that already does that.
Yeah, I saw that like a buffer util.js.
I think it's buffer. Yeah, buffer utility.
Yeah.
Okay. So then you'll get the result should be that you have an async function, and essentially you have mostly awaits, in the flow, and not many callbacks. And the only callbacks might be when you need to construct a custom promise in some cases too.
Yeah. So if I understand, so you can say that we can do a await here, then handle the stream afterwards. Is that right?
Right. So it will be like a const read stream equals await. And the second thing is that let's see here. So I see that you have a self equals this, and in many cases we already managed to get rid of it, but I still have like very niche cases where I saw that we might need it if we have a class and one of the methods of the class wants to create something like a secondary object instance inside, which might be the case here. I'm not sure. So where do you use self here?
Well, I said here, I think I remember, I haven't thought about through why, because why, in this case, the context of this,
So yeah, so I'll tell you why. So the thing is this: an actual JavaScript function creates a new this context, right?
Yeah.
However, an arrow function does not, and retains the same context of the function above. So by changing the missing part getter to be an async arrow function, so instead of writing async function and then the argument list and then the curly braces, you'd write async, then the parentheses with the arguments, and then an arrow to the open parentheses. Then your context of this will be the same, and you can just call this dot get This dot read hub object stream.
Okay. Okay. So basically, if I change this one to be error, or if maybe I change this one to be function, is that good?
No.
No.
So we
Okay.
use functions. We typically just use them either in top level modules. So you'd like to export some function, you define a top level function. But in many cases, when you write functional things into classes, like in this case, you end up not needing function like the keyword function that much. Because you're never really creating them. If you actually create any function internally to a method of a class, you typically use an arrow function just to to keep this context the same one of the object instance, right?
Okay.
So that's the way that we typically write these things. So that will help you here. And async await will also simplify a little bit this flow on buffer util, so that will be better. Okay.
Cool.
And eventually we get to just submitting this to read object stream with the same params. Okay. Okay.
Yeah, so I can probably 3 things here. I can change this one to await, to use buffer utils, and also fix that. Okay, cool. Hopefully I can still read my notes.
We'll have the recording if we need. We'll also, I think it's better if we go over later, and I'll add these as comments to the PR as well, so that we make sure we that. So that's good. Let's dive into the meat of the function of the read hub object stream, I guess, right? So that we understand how that operates.
This one, okay.
Yeah.
So this function handles both, the hop range read case, basically just basic function to handle all the scenarios, try to convert, different kinds of operation together, and then it's also going to upload either part and object to cache. So like I say, if hop read is a range read, basically is this input parameter tells that if it's set, okay, it's going to be a hop read or going to be a range read. So then it's one thing that I would like to point out, after besides setting start and end to used to read the hop, this one this if logic or this path of range read path also set if match tag header. Okay, so what it means, like since if we have the object cache, right? So we would like to read the same version of object in hop. If someone changed object in hop, we don't want to read a different the part of different object or different object content back into cache. So if so, we would have the cache would have mixed data inconsistency. Basically, some part is from old version, some part from new version. So this is if match e tag is going to make sure we can always get the part with the same e tag. So yeah, they relate to that. So if if read object stream gave failure because of if match e tag, so we base in here we're going to invalidate that object in cache. Okay. Just make sure we we can cache the we remove the old the old version of object. Okay. So next part is once we have the hop read stream, returned
Can
hop
I
read.
ask? Can I ask maybe a small picky thing? So
Yeah.
when you I see that you set if match e tag only in the case that it's arranged, that there's a range, but
Uh-huh.
can we perhaps make the condition specific to this so that if there's an object MD e tag, we supply that? Because I would say that um,
The case we don't run into, yeah, that probably is fine, but we never run into that scenario. Basically, we will not read.
the case that I'm thinking about is if we read the entire hub object, we
Yeah, yeah,
aren't we?
yeah. But
So
if we read the entire hub object, that probably would mean we don't have the object cached. You see what I mean?
yeah,
Yeah,
but still, you're right. But we have the metadata cached already.
we could.
Yeah, and we
Yeah,
don't want
yeah,
that to be mismatching.
yeah. It probably, yeah. Uh, that probably does. Yeah, that doesn't hurt. Can move. Can remove this one. Yeah, and not move, like basically move out of this if box. Okay. Yeah.
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 So depending if so we expect to have what I think is that we do expect to always have an object in metadata, and I suppose that also the e tag should also be there, like unconditionally in this case, in this flow. I think so. I mean, unless we plan to run this without pre populating the object metadata. Or so maybe the question is when are we actually putting the object metadata?
You see, for entire object cache, right? So that'll be object metadata is created at the
At the end of the upload.
in the beginning of upload. But at that time, I don't recall whether there's a e tag has been set. E tag probably has been set at the step of complete. Okay, you probably have the scenarios, some really narrow time slot, which is e tag is not set.
I see. So maybe still the so what I said is wrong. Then we are going to get here with both an e tag or without an e tag, depending on if the object is cached or not. But this case will also be more precise to be that if we got here with an object metadata e tag, we want to make sure that we read the same one and not. Okay.
Yeah. Okay. So.
Go ahead.
So then, this stack is basically going to connect to whether we should connect to a range stream. So if S3 client, S3 client read is range read, okay. Then remember, like one hop read is always aligned read here. So we're going to calculate what's the final start and end of that whatever the part or either object to be read from the hub. So this calculated that, then create a range stream, then let hop read stream type to that range stream, so that we always return in this, we return the specific range set by S3 client read. So that's this if logic is going to connect. If client read is range read, it's going to connect hop read stream to range stream. And this, as I mentioned last time, this is a new class which is specifically just return a range of data from a stream. Okay.
So Right. So I saw that in the PR itself. Can we focus just for a second on the case which we use it? So we're saying that this is for arranged hub read. Sorry, for ranged read, right? For the
Mm-hmm.
the client submitted a range for
Mm-hmm.
the GET request, right?
Mm-hmm.
And then we are aligning up and down the boundaries of this range.
Yeah.
So we are reading more from the hub,
Yeah.
right? So we are updating the start and end offsets to the aligned offsets. And now we're running with these. So we're sending the read requests to the hub
Mm-hmm.
with these. And now um, And now why? Okay, so the question is maybe this.
Mm-hmm.
When we are in this flow, we are already in a um, sort of a direct. Um, let me phrase this. Um, so if we pass on the alignment, maybe here, it will also be pretty simple to trim out the things that are not needed. But I'm trying to figure out if what I'm saying is correct or not, because I might be wrong. So if we are pushing out so if we are calling reads on this function, and these reads are limited either to 4 megabytes,
Mm-hmm.
right? Or I mean, not really, right? It can be unlimited range from the hub, which is missing in the cache, right?
Yeah.
Is that right? So when we're calling the missing part getter,
Mm-hmm.
are we calling it for every 4 megabytes, or are we calling it for the combined range, like I
It's
think we discussed
combined
it.
read.
Combined,
Basically combined read. It could be a multiple of 4 megabytes. Yeah. Yeah.
right? But then it will be aligned
Yeah.
to. So even if it's long, I mean, if the range is long, it will be aligned.
Yeah.
Um, and then it doesn't really matter, because the caller, which is is the stream doing the read, the normal read. We just provided the handler, really expected the aligned request that it sent here, right? It didn't really expect it to be sending any unaligned offsets in this case, like
Okay.
you said before, right?
Yeah.
That's when we're using the stream reads. When are we really getting like alignment changes here? When we are reading a part from an object that is not cached, right?
Yeah.
And uh, I see. I see. So that's the case, really, right? So
Yeah.
whenever we read a part from an object that is not cached, we will get to this case where we have different offsets for the read versus different slices that we want to perform. Okay. Okay, I see now. Yeah.
Okay. So that's the connect to the range stream for returning us the range specified by S3 client. So this group, from now on, the code will be regarding upload to either object, entire object to cache. Okay. And then this if check, we're going to basically to check whether we have reached the maximum cached object size. The total size to be cached, whether going to exceed the maximum configured maximum cache object size. So if it's exceeded, we will not going to upload to cache. Okay, just going to return the the stream. If
So basically, this means that for large objects, we will likely cache only the first piece of it, right? That's the logic here.
Yeah, it's going to cache up to this size configured, maximum cache object size. Basically, if it's a, this one will be a 1 terabyte, going to be cache up to 1 terabyte. The total, the total.
I agree.
Yeah.
But the notion I was trying to understand, and I think I understand now, is that I am dropping the incoming. So it's not that I'm pushing off older things, right? In this case, like we do for
Yeah.
the entire cache, but
Yeah.
in per object, since we don't have an LRU per object for pushing or doing things like that, we just say that we will drop the current buffer.
Yeah. If it that's if people tend to read the most recent part, then you will always read from part.
So the one pitfall I think about with this is that if this size, if the configuration here, it somehow needs to be proportional to the cache size, right? To the storage size, even.
Yes. I guess so. Yeah.
Yeah. So because otherwise, or maybe we should say this: if it is not proportional, if it is, let's say, much smaller than the cache size, then let's say it's a gigabyte, for example, right? Then it means that no object can be fully cached, which is larger than 1 gigabyte.
Yeah.
Right. And this, I think, it just means that we will need to update, like to change this configuration to be something realistically high enough for that. Expectations about single object caching will be met. I'm just thinking if we can have this, like if we can make a simple improvement and get less, dependability on this configuration, because we might need to update this configuration for different cases. Which, it's okay. We can do that. It's not too complex. But maybe we should keep it in mind. We'll see if we have more ideas.
Yeah, and a nice case, I don't know how difficult to do. It's just rely on upload error. If upload error can specify not enough room or storage, then that's probably just fail it, right?
Right, but the write will try to. So there is an option like this, but we can do it still. That we will never really try to move chunks synchronously from the write flow. This is, I think, what you were suggesting, that we actually fail if there's no room to the cache. And I think this makes sense, because what this means is it's not really a consistent reply that we will not cache anything with this object anymore. It's more of a transient response saying, okay, so we have a worker. The worker is working on getting rid of things, but in this case, it didn't have enough time. But we don't want to spend time here. We're just going to drop right now for this case, and we'll try to throttle maybe the worker more. That will be a configuration we might have. How much throttle we want to have the worker do, right?
Yeah.
So I think you're right. I think we need to somehow keep that in mind, that we want to do this, so that the write path will in the caching case will not call synchronously to make room, but instead just maybe we should use this same case there, so that if we're in the caching case, we somehow signal the worker to on the pressure, right? Because we don't want to lose maybe the track that the pressure got ended up to drop a buffer. So that's the kind of event we probably want to communicate. Okay. That's good. That's a good point. But I think the object size, the max object size, for me, it seems like a more difficult configuration to tweak at this point. I mean, I would just set it to a big number at this point, and it will be difficult to do much more.
Yeah. Yeah, I forgot that currently it's at a smaller size, just for testing purpose. I can change that to a big number. So these, so within this block, also same thing is going to use the heart rate range input as as a condition to determine whether we're going to do a entire object.
Oh, you know what? Sorry,
Uh-huh.
I just had a small idea. Maybe we can make that work. Maybe we can put a limit which is relative to the bucket free space, or to the bucket use space or bucket free space, either one, like total space, and say that if the object consumes more than 80% of the capacity of the cache, or say whatever, like 50% or 30%, whatever the number is, then we probably want to stop caching this object, because it's we just don't want to starve everything else.
Okay, so is that free space, is it currently supported metric? Like, if I can
Yes.
read. Okay.
Yeah, so what we need to make sure that we have this information in this context before we actually go and do the actual upload. Maybe we will end up making this check inside the upload instead, like we said with move chunks, right? In the same location, we said instead of moving chunks, let's check something. Maybe that's the case, right?
Okay. Let's see. Yeah. Anything else?
No. Let's finish just the flow. If we can see the rest of the.
Yeah. So yeah, if hop rate is range rate, so going to, in that scenario, we're going to upload a part to cache. Otherwise, going to upload object to cache. This one probably I should use the same thing, like set immediate call for this one as well.
To submit, you mean?
Yeah, to submit. I should do that. Yeah.
Okay, so here's the thing I was trying to I was pushing for. So instead of just submitting something here to the void of the timers that it's not really we don't have much control over how much we submit, how much pressure there is on submissions here, how much memory we keep for that, right? Because we can end up submitting 1,000 uploads here, and that each one will will put its own, like maybe even more. I'm saying each one will keep its own buffers from the read, from the hub, and then is keeping them in order to write to the cache. And I think what we should have here instead is just some small component, and I've tried to name it something, I think in the discussions we had, something about cache. What was that? Something manager, like managing buffer manager or something like that, right? And the intention is that it will be able to do some accounting of how much buffering we are keeping in memory here.
Okay.
And we have a semaphores. solution we typically use. However, the question is, semaphore will help us wait here. The question is if we want to wait, or I think what we want to do is drop, right? So it's not. I mean, the semaphore here is really not the case, but more about we just want to counter. We just want to be able to count how much incoming, like in-flight buffers, we are actually, keeping here.
Okay. So then in that case, we should treat those scenarios the same, like right.
Yeah,
So
I mean the actual class, or the instances we're talking about doing this accounting can be very generic. Doesn't really have to know much about what is happening inside. Just needs to be able to say, well, this is the job and this is the the weight of the job, I suppose.
Okay. So is that one going to be a global layer or per bucket level?
No, so I think it's a memory management issue, right?
So basically, it's a global thing then.
Yeah, exactly. It's about the memory of this process. This is what we're trying to throttle here.
Okay. Yeah. Cool.
But you can certainly make this a utility. We have a bunch of similar things. Maybe you can browse in the SSC util, see similar examples of things like that. Some of them require some async, callbacks. So you return a promise or do async functions like that. But some of them are really just synchronous, very simple utilities, just doing the accounting and running the job later on. And that's it, right? And ignore any errors, just log them or something like that. So
yeah, I can take a look at object. I believe it uses the semaphore to control the basically throttling. I guess it's throttling the
yes, semaphore will definitely throttle, but in this case, the throttle what we're doing is different because semaphore is used in order to make you wait, right? That's the function that you implement. And in this case, we don't want to wait. So
we want to just like drop if it's to manage.
Or maybe, you know what, the other option we can have here is maybe a timeout semaphore. We have that actually supported in the semaphore, so that we can wait but a limited amount of time with it. Or I don't know, maybe it's simpler to just drop because we are already counting the memory usage. So we know the memory usage is high, and we have the queue there. So I don't know. I suppose it's useless to really wait some more, right? We waited as much as possible.
Okay. Cool.
Okay.
I can look into that. That shouldn't be very hard to do.
Okay, and then basically this ends here by returning the stream, either the range, so the slicing stream, or the hub read stream, right?
Yeah.
Okay, got it. So that covers, I think, most of the range flow, the range read flow, right? And we are also out of time. I think there's, other than this flow, there's the API things, and there's the actual call to upload upload range part here, which we didn't cover, right?
Yeah. So those are actually simple functions.
This one is calling the new APIs, basically.
Yeah. So there's the object.
So you know what? I think we will stop anyway at the end of the hour. I still want to have, like, I think we will do a finish up meeting to do that. I'll post the comments on GitHub so you can go over that. What we discussed. If there's anybody else wants to add something, feel free. I'm not trying to take over.
Another thing, if you can have time, you can take a look at API, the object server.js, compare like between the start object start upload start part upload procedure and the create multi-part procedure. I think that there's a you'll see like well probably will help you to decide whether we really need that procedure or not, like start part upload procedure. I think we need that. Because I go back check again, those two procedures, it's a deal with two different things. Even though
So I didn't think about that one. I understand what you're saying. I agree. I don't think that the multi-part, start multi-part and complete multi-part or finalize. I forgot which one. So I don't think they are a candidate for replacing. I don't think that will work. But I think the only case I want to check is if the existing flow that does get mapping and put mapping, if these calls can be like already be doing what we are doing, with this, creation of parts. Or sorry, you say, I keep forgetting. I think I keep mixing up. Are we creating the object or the part there?
Part.
The part, right?
I create the start object upload does not doing anything, does not modify the no, I'll take it back. It just modified object metadata.
Right.
But it doesn't have to. So it's mainly it's returning the it returns the a chunk config
and stuff like that. Right. Yeah. So I remember. Right. So we need to basically see if we need if we have alternatives to these, which are simple enough at this point, and we don't have to use these extra calls in the flow, because this will be somewhat of a repeating call. We will do this call and then we will do get mapping, put mapping anyhow, because that's what we do during upload, right? So the question is if we can get rid of the these two other calls between. Okay. So I'll set up another call. I think, but I think we covered most of the flow. I don't think we will cover in the sessions the tests though. So I don't know if there's a plan to go over all the tests. If Nimar, do you think you want to do anything specific with the tests, or you want to keep it part of the general review here? Not sure if you're still here.
Yeah, I'm still here. I don't know if we want to do online for the tests.
Okay.
I think it's even if we have some issues, it's not as bad as code that runs.
Right. I mean, from review purpose, I mean, we don't have to. We don't have to review
exactly.
Technically. So I think the question is for you, Paul. If you see specifically a question, or if you want to bring up any, maybe dilemmas you had when you wrote the tests or whatever, then feel free to highlight that. Maybe in the next session we can go over anything like that if you have.
Not really. The reason I create tests because it's difficult to test the scenarios. So if I modify one line of code, I cannot manually test those scenarios. That's why I create the test, automated testing, just use to validate the purpose. Okay.
I agree. The motivation is perfect, because that's why you really need tests where it's really hard to replicate the same.
Yeah. So it helped me just make changes. Help me quickly validate whether it's still good or not. Without that, it just it's too difficult to verify any changes.
Yeah, I agree completely. Okay, sounds good. So I hope we'll have enough coverage next time, so we can merge. So the beginning of next week. Does that sounds reasonable?
We'll shoot for it. Next week I probably take a couple of days off. We'll see.
So let me know Okay, so let me know if you have specific times you want to you want me to focus on the work that or the meeting or whatever, if you want us to be available. Okay, so just
Yeah, I think maybe Guy, perhaps instead of having these meetings last week, if it depends if Sanjeev is sick today, but if he's sick again next week, perhaps you could use that time to just set aside for just reviewing, but without the meeting, and providing feedback. We mentioned that.
you mean the PR from Sanjeev, right?
Yeah, I mean, review any PR of us that you think should be reviewed, but just instead of having the meeting, if it's not possible, then just set that hour aside for you to have. This is a review time.
Of course. So we'll make it push, but I also want to have at least some time for comments and fixes in between these sessions, so that we will see, also have a chance to see the entire picture, right? So I know it takes like a week to get that reviews, but I think it's I mean, the PR is big. I think it's good that we're doing it over a week. But in the case of the next PRs, I agree. I mean, we can, if there's some problem to schedule, we'll do that. Okay, so let me stop the recording with all these synchronization things at the end. Okay.